Hello everyone, you are all welcome to lecture number 965, and today's topic is the industrial manufacture of SBR or Buna S rubber by hot and cold process. So mainly there are two processes which are used to manufacture SBR rubber. In the case of hot process, it is first we have to prepare the emulsifying agent, and that emulsifying is mainly the emulsion of soap, that is 5 to 10%, and temperature is around 50 to 55 degrees centigrade, and here butadiene is 72 to 75% plus styrene is 27 to 30% is added, and also reducing agents are also added, and initiator, and they are actually potassium persulfate, and this mixture will be allowed to stay for few hours, and in this case the conversion to rubber SBR is up to 60%. And the second one is, that is your cold process. In the case of cold process, temperature is from 0 to 5%. Usually it is maintained up to 5%. And here in place of reducing agent, we are using free radical reaction mechanism. And for free radical, we are using usually benzoyl peroxide or sodium peroxide. And these free radicals, they are very effective. And the free radical and polymers, they coexist in a very balanced way, and the conversion is more efficient, and also the quality is good. That's why the cold process is having more advances, and this process is the one of the latest one. Otherwise, in most of the cases, it is the hot process. So this I am going to give the chart of these two processes, and to understand this manufacture. So here in chart, it is given the industrial manufacture of SBR rubber, and how butadiene, styrene and copolymers they are mixed, added, and how product is obtained and shipment is done. So first on top is that the butadiene will be here in this place, that is charge heater. It is heated, then Hornby reactor, it will be passed on, then quench, and after that compression and absorption chamber, and after that CA extraction, and that product will be directly coming to monomer here in that tank. That is a tank form. The second one is ethylene, that is ethyl benzene, and then catalytic dehydrogenation tank, and then BTX distillation. Then the fourth one is ethyl benzene distillation and styrene concentration. So after that tank, that one is also sent to monomer tank. This place is where these two, butadiene and then styrene, are sent here, and that is monomer tank form. Then from here it goes to copolymer reactor, and then it is recovery is done. After the recovery, it goes back to monomer tank former, that is copolymer, and then after that it will go to latex storage, then coagulation. After the coagulation, then it will come to the process, drying process, then boiling, and after that the final one, that is shipment. And here the soap activator catalyst means it is emulsion, emulsifying agent, plus salt stops modifier inhibitors. So these two are as a raw material. It is added to pigment precipitation, and that pigment precipitation will come here to copolymerization reactors, and here all these things after process is added, and then again it will pass to electric storage, and then finally we will get the product ready for shipment. So this is your flow chart of manufacture of SBR rubber or Buna S rubber. So that industrial, outline was given about the manufacture of SBR or Buna S rubber by two processes, that is hot and cold processes. And these two processes I have discussed here. Number one, hot process. In hot process, butadiene and styrene is taken in proportions as mentioned here, are polymerized in a soap emulsion at 52 degrees centigrade temperature and 45 to 60 psi pressure. The composition has butadiene 71 to 75%, styrene 25 to 29%, dodecyl mercaptan 0.5%, it will act as modifier, and potassium persulfate, that is 0.2 to 0.3%, and it will act as initiator. Soap 4 to 5% as emulsifier, and hydroquinone 0.1% to stop the reaction, and phenyl naphthylamine 1.25% as an antioxidant, and finally water. The hydrocarbons dissolved in each other are formed droplets which remain suspended in the soap solution. Just like that's why emulsion, you know, that a droplet of hydrocarbon, those styrene and butadiene will form, and it will be suspended in this emulsion in the soap solution. Soap serves as emulsifier and potassium persulfate as initiator. The polymerization at about 60% conversion is stopped with inhibitor. So once there is 60% conversion into SBR rubber, so inhibitor will stop this conversion, and it has 60% butadiene in 1,4 transform and 20% 1,4 cis form with an average of 1 double bond per molecule. In each molecule there is average of 1 double bond. It is unsaturated. Number 2, cold process. Cold process is recently developed, and cold process of manufacture of SBR rubber gives better result at lower temperature, that may be from 0 to 5 degrees centigrade. Reducing agents are used instead of K2H2O8, that free radical is obtained by the action of reducing agent on organic hydroperoxide, act as initiator, and that initiator is as a catalyst. Free radical catalyst such as benzoyl peroxide or sodium persulfate have been employed. So free radical we are using as a benzoyl peroxide or sodium persulfate have been employed. The free radical helps the partial polymerization because of the fact that monomers and polymers can coexist more easily in presence of free radicals. The composition of the butadiene is 72%, styrene 28%, tertiary dodecyl mercaptan is 0.17%, potassium resin soap 4 to 5%, and sodium hydroxide is 0.2%. So with this I will stop. Thank you very much for watching the lecture, and in the next lecture I am going to discuss some chemical physical properties of SBR rubber and some important points for students. Once again, thank you very much for watching the lecture.